Backend systems usually need to make a lot of calls to external services. Processing single business operation might require several calls. For example, to process a purchase order, the backend might need to call inventory system, payment provider, and delivery service, and these calls should be made in the correct order. However, network communication is not 100% reliable. Sometimes there are connection errors, HTTP 500 responses, or request simply times out in the middle of the process. Backend must handle these situations properly, otherwise the business operation might be left in an inconsistent state. On top of that, we rarely run just a single copy of the application. In production, we usually have multiple instances running in parallel, all sharing the same database, and they need to run side by side without collisions or data corruption. One of established ways to build reliable backends is to use the database for coordination. The Doer library facilitates this by persisting each business operation as a row in a tasks table, which is updated as operation progresses, making progress remain durable, visible, and recoverable if application crashes. Each task has an in progress flag to guarantee that only one application instance works on it at a time. A status field that represents the current step in the business workflow, and failing since timestamp that records when errors began, allowing us to do controlled retries and clear handover to failure handling or compensation flow if necessary. So I repeat, the Doer library uses the tasks table in the database to track progress of business operations performed by the backend. And usually the business data lives in the same database, and this makes this solution very reliable. Of course, like everything in software design, this approach comes with several trade-offs. First, the business operation must be split into smaller retriable steps. Then each step requires a short transaction before execution to set in progress flag to true, and another transaction after execution to reset the flag and update task status. In return, we get relatively simple setup, just the database and the application. Transparency, since SQL can be used to query both the current state of business operations and their processing history. And resilience, as long as the database is fine, unfinished business operations will continue on another application instance after restart. I would like to show how this approach looks on the database level. Here, Doer tutorial, a demo business order processing application, just one business operation, 5 steps in Happy Path, including 3 REST calls. I will run its Happy Path integration test and show what SQL statements were run on the database. In this IDE, we need to disable incremental annotation processing. And then in the integration test configuration, we need update configuration for Docker, for Postgres Docker image to log all the statements. And then we run the test. It takes about 10 seconds to start Docker images. Okay, we open this pgr file, I highlight transaction. So we scroll down to this insert into order statements where order is created. Together with order, the tasks row created. And before first step, task in progress flag set to true, order loaded. And then after first step, task in progress flag set to false and status updated to order processing started. Before next step, true. After next step, in progress false, goods received. True, false, order paid. Then order shipped. And then after the last step, tasks in progress flag set to false and status set to null, indicating that business operation is finished. As you can see, this one business operation of 3 REST calls was split into 5 steps, which became 10 short transactions in the database. At the same time, all these updates makes clearer history in the database of business operation processing and makes our system always prepared for recovery. With the simple idea of using the database for coordination, the Doer library helps build backend systems that stay consistent and transparent, works well in cluster deployment, and recover gracefully.